Hello, today we are talking about Taylor and Maclaurin series. So I apologize for my screen. For whatever reason, I can't get these series to come up, and I'm not sure why, but look at your paper as opposed to looking at the screen right now. I'm not really going to do any writing. Right now we have definitions of Taylor series and Maclaurin series. So the first big series that you have, which doesn't really look like this one is a Taylor series. The difference between a Taylor series and a Maclaurin series is the Maclaurin series is specific and your A is equal to 0, which means the Maclaurin series is good around 0. So for those of you who like to memorize, that's what this one's going to be all about. So the partial sum of the Taylor series is the Taylor polynomial, and that's the formula right there, which of course we can't see on the screen, but you should have it. The next thing that it shows is some things that you need to memorize, and you actually do need to memorize these. There will be more, but we have e to the x, we have sine of x, and we have cosine of x. Now, I don't expect that you memorize them right now. We're going to use them right now in the examples, but you must memorize all of these. Okay, so memorize these, and again, there will be more, but right now, those are the ones I'd like you to memorize. So we can find Taylor series and Maclaurin series, which again is a polynomial that is approximating a function. What we've done already is equating derivatives, and we've done that, and that is what that very first formula at the top is. That's using our derivatives, dividing by the exponent factorial, and that's what we've already done. So the next thing we can do is operating on a given or known series. That's what you really want to do. That's one of the easiest ways. So we're going to substitute for the variable in the series, multiply or divide by the series, add or subtract your series, or integrate or differentiate the series. So knowing those, without knowing those, you can't use this step at all. Next, we're going to recognize the sum as a geometric power series. It is important that when you see a power series, you recognize it and you know how to find that sum. And then we can also operate on the parent function using long division, integration, differentiation. Okay, so let's actually do some examples. So example 1, we're going to find the Maclaurin series for f of x equals sine of x squared. Well, once I see sine of x squared, I should automatically think, well, what is my Taylor series for Sorry, we're doing a Maclaurin series. We're doing an x is 0. What is my Maclaurin series for sine of x? So that is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus dot, dot, dot. This says it wants the general term as well, so I would go ahead and include the general term, negative 1 to the n of x to the 2n minus 1 all over 2n plus 1 factorial. And again, you need to memorize that. That should just come falling right out of your mouth at any time. So now, instead of having sine of x, what we actually have is sine of x squared. So this is as simple as it seems. We're going to do sine. Instead of x, we're going to plug in x squared. So that's going to be x squared minus something cubed over 3 factorial, and instead of having x cubed, it's going to be x squared, and we're not going to simplify, plus something to the 5th over 5 factorial, and that something again is x squared, and then we're going to write our general term, and it's still negative 1 to the n. It's going to be something raised to the 2n minus 1 all over 2n plus 1 factorial. And again, instead of having an x in there, we're going to have an x squared. So that's all that was. Substitution, again, once you know the series for sine, simple. So next one is just as simple. So what I would like for you to do is give this one a go. And again, it is just as simple. So please try example 2 right now. So here is my solution. I just took the cosine series multiplied it by x. You could have left it at the second line, and if you did distribute that x, you would end up with the green line. So we're moving on to example 3. And example 3 is going to go exactly like example 1 and 2. So first I'm going to start by writing out my e to the x. And e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. So there's my e to the x. So the next thing I need to find is I need the e to the x, but I also need e to the negative x. So I'm going to do a substitution, and I'm going to be plugging in negative x instead of x. So it's 1 plus, and again, instead of an x, I have negative x. Now, when I take negative x and I square it, I still get x squared over 2 factorial. That one doesn't change. And then over here, I'm going to get negative x cubed. And again, over here, I'm going to have negative x raised to the n over n factorial. So now I just need to plug all this in into what I wanted. So what I wanted was e to the x plus e to the negative x over 2. So I'm going to go ahead and just take the 1/2 out, and then I'm going to have e to the x plus e to the negative x. Now because they're lined up the way they are, I'm going to go ahead and add. So I'm literally going to do this. I'm going to put a little plus sign right here, and I'm going to add these two things together. So 1 and 1 gives me 2. X and negative x, that cancels out. And then I have 2 of these x squared over 2 factorial terms. My x cubed terms cancel each other out with zeros. I'm going to end up having 2x to the 4th terms. I didn't show it in my listing above, but I think we should be okay that I would have 2 of those. I would have no x to the 5th, and again I would have 2x to the 6th over 6 factorial. And then I would end up with the next term, my general term. Again, I'm going to add these two things together. So it's going to be x to the n over n factorial plus negative x to the n over n factorial. And that will take care of when I have zeros, the two terms cancel each other out because they're opposite signs, and when I'm actually combining them to make 2 of that single term. So for example 4, we have this thing, which looks kind of icky. Looks very, very icky. So first thing that I could do, there's 2 ways that we could do this. One way I could recognize that this is close to 1 over 1 minus x, but what I have done is a substitution, and I've substituted x cubed in for x. And then what I did is I ended up multiplying that by an x. So if you see it that way, hopefully that you do, we're going to start with, again, one of the series on the front. This series isn't listed on the front, so I apologize. This is a series that we need to know as well. Let me write it down. You need to write it down. 1 over 1 minus x is 1 plus x squared plus x to the n. Okay, so again, I apologize. That's one you do need to memorize. I thought it was on the front, and it's not. So this is a series that you need to memorize, which is why you probably didn't recognize what the particular r was going to end up being, but hopefully now you see, once you know this, we can do this one. So what I'm going to do is I'm going to do a substitution. So first thing I'm going to do is I'm going to have 1 over 1 minus, and instead of having an x, I'm going to have an x cubed. So that's going to be 1 plus x cubed plus x cubed squared plus x cubed to the n. And then the last thing that I need to do is multiply this by x. So I'm going to have Now my whole thing will be x over 1 minus x cubed. And all I'm going to do is have x times, and then the series that I just had, which is my 1 plus x cubed plus x to the 6th. My next term would be x to the 4th squared, which would be x to the, x to the 4th cubed, excuse me, x to the 4th, my next term would be x cubed raised to the 3rd power, and then my next one would be x to the 4th raised to, x cubed raised to the 4th power. So my next term is x to the 9th, the term after that is x to the 12th, and then my general term is x to the 3n. And again, I need to multiply that by x so I can distribute that. And that leaves me with x plus x to the 4th plus x to the 7th plus x to the 10th plus x to the 13th plus x to the 3n plus 1. So there you go. There's our Maclaurin series for example 4. There is a way to do it geometrically as well, noticing that your first term is going to be x and that your r is going to be x cubed. And again, if you see that, that's fine. If you don't, that's fine as well. I'm going to go ahead and move on to example 5. So example 5, find the 4th order Taylor polynomial that approximates y equals cosine 2x near x equals 0. Now 4th order means I'm going to go up to the 4th degree. And again, I'm just going to do a substitution. So I start with my cosine. And that's as far as I need to go, because I only need a 4th degree, 4th order. Write my general term anyway. And again, I'm doing a substitution. So instead of an x, I'm going to have a cosine of 2x. So I'll have something squared over 2 factorial, and that something is 2x. And then I'll have something to the 4th over 4 factorial, and again that something is 2x. And then I'm going to have my general term, and again I'm going to have something raised to the 2n over 2n factorial, and that something is going to be 2x. So there's cosine of 2x. Moving on to example 6. So for example 6, we have a function. We don't know what that is. So this one's different than all the other ones. We started with a sine or a cosine or an e or a something over 1 minus x. And now we're going to write the 3rd order Taylor polynomial for this function at x equals 1. They want to use it to approximate the function. So the first thing we need to do is get back to our original Taylor series. So that's from the front. I'm just copying this down from the front, where we have f of a plus f prime of a, x minus a, plus f double prime of a over 2 factorial times x minus a squared. And again, this should look familiar. This is what we were working on previously, is finding these constants in front, and they are the 3rd derivative, obviously, divided by 3 factorial, and then my term is raised to the 3rd. So once you see this, we just need to figure out what everything is that we have. So the a value, a is the x value we're kind of going around. And in this case, our x value is 1. So they told me that 2 places. They told me right here that x was 1, and if you look at all of these, f prime, f double prime, and f triple prime were all at 1. So my a value is going to be 1. So knowing that, we should be able to substitute in now. So my polynomial is going to be f of 1, and f of 1 is over here. That's 4. plus f prime of 1, which is right here, negative 1 times x minus, and again my a is 1, plus we have our f double prime. F double prime is 3 over 2 factorial times x minus 1 squared, and my f triple prime is 2 over 3 factorial times x minus a. Sorry, x minus 1 cubed. And again, it told me to do the third order Taylor polynomial, which means I have done that. I am up to the third, raised to the third power. So here I have my p. So the next thing it wants me to do is approximate f of 1.2. So f of 1.2 is going to be approximately 4 minus 1.2 minus 1, which is 0.2, plus 3 over 2, or 3 over 2 factorial, times 0.2 squared, plus 2 over 3 factorial is really just 1/3, times 0.2 cubed. And at this point, I would just use a calculator to calculate that, and I believe we get 3.8626. So that's the approximation of this function that I don't really know too much about at the value of x being 1.2. So for part B, we want the second order Taylor polynomial for f prime. So I already have my p, which is approximating f. Let me scroll so I can see that. And so really what I want is f prime should be approximately p prime. So all I'm going to do is take a derivative. So the derivative of the 4 is 0. The derivative of this thing right here ends up being just negative 1. The derivative of my next term is going to be 2 times 3 over 2 factorial times x minus 1 raised to the first times the derivative of the inside, which is 1. Derivative of that last term is 3 times 2 over 3 factorial x minus 1 raised to the second power times the derivative of the inside, which is 1. Now it should make sense why this question only asked for the second order Taylor polynomial, because the only polynomial I had was a third order. So I found my derivative approximating at using values of x around 1, and now we're going to approximate f prime of 1.2 using this. So that will be negative 1 plus, this should simplify to 3, and again 1.2 minus 1 is 0.2. Looks like this term simplifies to a 1 times 0.2 squared. And we could then pick up our calculator, and I got this as negative 0.36. So we have now done using substitution, using multiplication, using addition with series that we know, and by using just a plain old formula for a Taylor series, how to approximate a function. So please bring any questions that you have to class, next class, and have a wonderful evening.